All right, from the one in the packet, reading through it carefully, you would see that the number of security guards is based on the number of blocks. So however many blocks we have, that's how many security guards. And that's what part A is asking for, is how many security guards, which is also going to be equal to the number of blocks we're going to have at the concert. All right, well, what's a block measure? According to this problem, what's a block measure? 25 by 25, all right. And then the concert space measures, I didn't want that, I wanted a rectangle. And what's the concert space measure? 350 by 200. What they're asking is, how many of these can fit into here? How many blocks can fit into the concert space, which will give me the number of guards? All right, well, we had to do a little area here. 25 by 25 gives you 625 square feet. And then 350 times 200, what did that give us? 70,000? Okay, so there's an area of 70,000 in the entire concert, area of 625 in a block. How am I going to find how many blocks fit in? I can divide. So number of blocks, which is also equal to the number of guards I'm going to need, is going to be 70,000 divided by 625, 112 blocks. Or in this case, 112 guards. Okay? Everyone good? Not bad. And then part B, how many people are going to be in each block? All right, well, how many people go to the concert? 12,000 people at the concert. I have 112 blocks. How can I find out how many I can fit in each? 12,000 divided by 112. But notice the directions. I don't know if anybody got thrown off here. Nearest 10. So we're talking 110, 120, 130, 140, etc. That's nearest 10. Not 10th, not 10th, nearest 10. So 10s, 20s, 30s, 40s, 50s, etc. So you go to the calculator, 12,000 divided by 112. Here's what ends up happening. You get 107.1428571, but to the nearest 10, we're looking to put about 110 people in each block. Probably not on the regions, but maybe on the unit test now that we did it. Everyone all good with the one there? That's a great question. That's a Regents level question right there. Maybe not the rounding here, but good Regents level question. Go to the book. What do you want? I copied out a bunch of problems from the book. I'm assuming I know which one one of them you're gonna ask anyway, but we'll take questions here. Let's go, Connor. Okay, here we go. 37. Was that the last one? Where it said challenge? I hate to break it to you. It's not. This was a challenge because you don't know what's going on, but this is going to be expected here in the unit. All right, where I just give you a figure. Maybe you can identify it. Like, all right, great, that's a triangle. Maybe you can identify it. All right, I don't care that this is a triangle. Heck, it could be a pentagon. It could be any type of sided figure. I don't care. I'm finding the area the same way every time, and it is not 1/2 base times height. All right, I know that's what some of you tried to probably pull out, but here's my problem with that. Where are you going to draw the height into what base, and then how are you going to find the length of that base? Okay, that was the problem for me. All right, because you can't just draw any line. Like, I have no idea if that's perpendicular or not. Probably not. The slopes have to be negative reciprocals. I have no idea. So if you looked on the answer key, I gave you guys a little hint on how to do this. And the way we're going to do it is we're going to box it in. We're going to box this in. How? I'm going to go from each vertex and I'm going to draw a box around it. Can you find the area of that box? Can you find the area of that box? Absolutely. So we have 1, 2, 3, 4, 5, 6. I got 1, 2, 3, 4, 5, 6. So the area of the box anyway is 36. And you'll notice when I drew the box, What type of figure? That's probably not a good color. What type of figures ended up here? The unshaded ones. These are. Can you find the area of those? Pythag. What are you doing? Pythag. How about the area of a triangle? So I'll have number 1, number 2, number 3, and sorry, that's not number 3. That's part of number 2. I got triangle 3, and then I'll have this little part right here, triangle 4. And then find the area. No, that's part. Never mind. There's only 3 of them. Get with the program. All right. Can you find the area of those? 1/2 base times height. And then what do I do with all 3? Subtract them from 36, and I'll have my area. Okay. That's going to be the same throughout the entire unit. Just box it in. Don't worry about a formula for it. Box it in, and most likely you're going to be left with right triangles that you can find the area of. We might do one later on where you box it in, and you're like, oh boy, I don't know what that unshaded figure is, and we'll have a solution for it. But for now, find the area of the box, subtract out the triangles. Do not, I forgot to bring this part up. Don't pull this business. Ready for this? 1 box, 2 boxes, 3. This looks like a quarter. I'll call that a quarter of a box and start adding up that, and that's not going to fly. Good luck with that method, by the way. Okay, good luck with that method. All right. What's up, stud?
Could you also find like the line perpendicular to AC that intersects B, and then like use that as?
Then you're gonna do 2 distance formulas.
Yeah.
You could, yeah. That's a lot of work. Okay, but yeah, you could. You just gotta. I'd be careful on how to find the length of that. Like, where does it intersect? Because you need to know that point too, where it intersects AC. If it doesn't come out to be nice to do actual distance formula. Okay, but yeah, it's a way around it. Okay. Anything? Let's go. Anything else here? I'm waiting for another one here. Meg, let's go. 31. Yes, glad you asked that because that's going to be more common today. These type of problems. It was find the perimeter and find the area, but it wasn't a 30-60 or 45-45 like we discussed yesterday in class. So I needed another method. Perimeter. Well, I already know one side's 3. Opposite side is also 3 because they said they were congruent. Well, what about the other 2 sides here? I'll call it X and X here. This is, everyone's in agreement, not a 30-60 or 45-45, but it is still a right triangle. It is still a right triangle. So I can use my buddy here, since it is a right triangle, SOHCAHTOA, to find that side. Angle 62, ready. What's the 3 acting as? Opposite, adjacent, hypotenuse. Opposite, and how about the side I'm trying to find? Adjacent, so out of SOHCAHTOA, which one am I going to use with the opposite and adjacent side? It is TOA, T for tangent. So I set up tangent of 62. What was the opposite side? 3 over X. I cross multiply. Tangent of 62 times X equals 3. What do you want to do on both sides? Divide by the tangent of 62. And then a little update. What do I not want to do with this number when I see it in my calculator? Don't round. You round the perimeter. You don't round the side lengths. All right, so I keep that full calculator display, and I add it twice, and then add it to 3 plus 3, and then I get the perimeter and round it. And then I can do area, which is just length times width, since it's a rectangle. And now I have that other side length. We good? I'm going to ask you to do that today, but with a different figure. Bless you, I'm trying to teach. Other questions? Anything else from here? How are we doing with the formulas? Because we're going to add on. We're not going to add on to the formulas today. We're just going to do the 2 that we didn't talk about yesterday. Anything else? Okay, let me see it. I gave you the formulas yesterday, but we did not go over any problems with them. So let's review real quick. Area of a trapezoid. Area of a trapezoid. Here we go. Look back at your notes if you need to. Let's roll. 14, you're up first. Area of a trapezoid. Thug life. Let's get going. Trapezoid. I don't know, 14? Dude, geez, what are we waiting for? I'm blaming poor Orion back here. Somebody help the poor kid out. Wasn't even here yesterday. And again, the B stands for base length. A trapezoid has two bases which are parallel to each other. Those are the ones we use. Rhombus. Oh, 27, rhombus. There you go. Yes, and let's review one last time. Are the diagonals congruent in a rhombus? No, those numbers should not be equal. Moving on, how about a kite? 26. Thank you, yep. Are the diagonals congruent in a kite? No, numbers should be different. Find the area of this kite here. Find the area of this kite. All right, so 1/2 diagonal 1 times diagonal 2. And as you'll see on that kite, just a reminder of some properties. The longer diagonal bisects the shorter one. If that needs to come up again. All right, so we're doing full, not part times part, full diagonal lengths here. 24, full diagonal, one of them. One job, Mr. Carlino. 13. 20 for the longer diagonal, 16 for the shorter, got it. And we're looking at an area of 7 when you're ready. Come on. Centimeters squared, just like we talked about yesterday. Now that we're in the area unit, centimeters squared. All right, everyone all right? Because that's great. You can just find the area. I gave you everything. You just plug and chug. All right, now example 2, a little bit different now. I give you one diagonal is 6 of a rhombus. The area is 48. Find the measure of the other diagonal. All right, so we're talking about rhombus. 27, area formula for a rhombus. Okay. What's the 48 represent in this problem? Here you go, 8. What's the 48 represent? So I'll plug it in for A, and then what other info did I get there, Colin?
You got the first diagonal.
Okay, so 1/2 times 6 times, looking for the other diagonal, X. Everyone all right solving that? I don't have to go through algebraically. We're okay. 1/2 times 6. Divide both sides by 3. And when you're ready, how about that other diagonal length? 30. 16 feet. I think we got a winner there, yes. Okay, real quick story here before I move on. I was getting the slides ready and everything today. And I had, I didn't know if somebody was going to ask this question where you had to graph it last night. Nobody did. That was fine. But getting the grid there, I also noticed this right here, that I can add a page background, like a different background to all the pages. Okay, so I decided, period 2, we've got a lot of inside jokes going throughout the year. So that's what I decided to do through not all the notes here, most of the notes. So here is, get rid of that. Here's the first one right there. All right, little page background. Okay, right there. So, okay, so everyone's going to have a little page background in a story, except for one slide. That's because you're going to do that problem on your own. But all right, so we got a little milk there, literally a little milk, strawberry, low fat. All right, so there's that one. All right, there we go. There's the next one. I don't need to reveal that one right there for Big Al's. All right, so example 3. Here we go. So you have a rhombus right now. And as we know, the area formula for the rhombus, 1/2 D1, D2, but I far from supplied all the information you needed. We are going to have to review some rhombus properties here. Diagonals of a rhombus. Let's go through them. Anybody remember anything? Orion. Perpendicular. That's where I had this hint come in where Pythag may be useful here. Still keep going. There's one other property I want to try to get out here. Emma? They bisect each other. Why is that important here? Well, if this piece is 40, so is the other piece here, 40. And now I can at least fill in one diagonal length as what? 80, yes. So one full diagonal is 80. How do I find the other diagonal? There's your hint. Anytime you're in a rhombus, look for Pythagorean theorem to be applied. Because I do have 50, I have 40, and now you can find this piece here. I'm going to need somebody to set that up, though. Go ahead, 14. Want to set that up, the Pythag for this one? Got it. Thank you. And what are we finding as the partial diagonal there? 23, 30. Be careful, don't plug that in. That's only half the diagonal. We know they bisect each other, so I won't plug in 30 to the formula. I'll plug in 60. All right. And then finding the area of this rhombus will turn out to be 4. What do you have for me? When you're ready, Emma, take your time. It's all right. 2,400. Watch your mouth. Square inches. Good. Everybody good? Questions? Good timing on that one there, number 4.
Yeah. We're so bad at that. It's gonna be star. It doesn't matter. Clock.
Okay, hold on. Calm down. Got them all. All right, ready to roll? Period 2 only. Here we go. Star. Genie. Was that? Curtains. Fades. Cube. Shatter. Clock. Slide right. Slide left. Pinwheels. All right, example 4, part A. Now we're in the trapezoid business. Leave your answer in simplest radical form. All right, well, let's look at the formula first to see what we need. I need the height, and I need the bases. I already gave you the bases. Okay, the bases are there. I need your help finding the height. So I have 6 plus 11 as the bases. Now what about the height? Maggie, what's up? Good. Sorry. Yeah, I could draw on the height. AD is a height as well. That's a height. I don't know if anybody could find that. Also, you could also draw in the height from vertex B. And that's probably a little bit easier because you do form what type of triangle? 45, 45, 90. Can anybody help me get a side? I have no sides, though. So right now, that 45, 45 is useless to us. Unless you get me a side leg. Maggie? Okay, the 6, opposite. Now you just made a rectangle here. So if that's 6, this is 6. So one side across from the 45 is 5, because the whole side was 11. The 5's across from what angle? 45, and the height is across from the other 45. And from yesterday, what do we know about the sides across from the 45s? They're always equal. So my height here will be 5. So I have 1/2, 5 for the height now, 6 plus 11. $15. What do you have for the area here? When you're ready. Okay, let me just, if the problem doesn't have units, I don't expect you to put some. If you want to do this little creative I've seen in the past, the U squared, yeah, sure, great. Okay, but if it doesn't have units, I'm not expecting. All right, next trapezoid now. I gave you the bases one more time. So now you're going to have to find the height. So the bases were 7 plus 11. Okay, we can do the same thing, but now it's a 30-60 triangle. 7, that would make the side across from 34. And yesterday, how do you find the side across from 60? Calm it down. 21. How do I find the side across from 60 if the side across from 30 is 4? Do we have a 21? Garbage. 27. Ready? Side across from 30 is 4. You okay? Now we got the 4. How do I find side? Oh boy. How do I find the side across from 60? Multiply it by radical 3. Yep. Yes, the game got canceled. We were rained out. I don't know. Yeah. Simplest radical form. Simplest radical form. So keep the radical 3 in your, here we go. Keep the radical 3 in your answer. 1/2 times 4. 2. 2 times 18. 36. Radical 3. That's what it would be in simplest radical form. All right. Questions there? All right. This one's going to be a little bit tougher, but I want you and your, couple slides too late. Find the area of Amelia's team pennant. Okay, within your group there, it's a little bit tougher than what we've been doing. It is a trapezoid. You only have one base of 10. You have no second base and no height. So I'm interested to see where you're going to go from here. So I'll give you guys a couple minutes, not too much time. Let's finish this one off. Okay, the height is already given. Here, there's the height of 4. One base is already given as 10. We just needed a little help finding the other base, which I'll put in yellow here, this base right here. I needed that base length to finish off the formula. So I saw many of you, oh, if that's 4, this height here also has to be 4. You make a right triangle, and you can do Pythagorean theorem and say 4 squared plus b squared. And when I'm talking b, I'm talking about this distance right here is b. Equal to that hypotenuse, which is 8.5 squared. After doing Pythag, you get b to be 2.5. No, you don't. 7.5. All right, that's this distance right here. Let's keep going. If the whole thing was 10 originally, that's 7.5. This will be 2.5, and this is a rectangle you just created, so the other base is 2.5. We're okay there. For a total area of 25 square inches. All right? All good. And then one final one. We probably should have fit this in yesterday, but there wasn't any time. Find the perimeter in the area of the figure, round to the nearest hundredth. I will let you know that it is a parallelogram, yes, and it's the shaded one there. All right, so we're finding the area and perimeter of this right here. Okay? All right, let's start with perimeter. Well, if it's a parallelogram, this is 12. This is 12. I need a little help finding the other two sides, though. Let's see. Can I get a little help from 25 here? Here's 35. What's the 4 acting as? Opposite side. And what about the side I'm missing? Hypotenuse. All right. SOHCAHTOA. O and H. O and H. What are we looking at? 16. What are we looking at with O and H? Sine. So we'll do a little work here. The sine of 35 equals opposite side 4 over hypotenuse x. Put it over 1, cross multiply. What do you want to divide both sides by here? Sine of 35. And we're not going to do what? Round a darn thing. So it's 12 plus whatever that decimal was, 4 over the sine of 35, plus 4 over the sine of 35. Now, if we want, we can round to the nearest hundredth. I'll wait for you guys to calculate that. Make sure you're in degree mode in your calculator if you've been playing around with it, having a little fun on the weekends. And nearest hundredth when you're ready. Here we go, 16 when you're ready, nearest hundredth. Nice, 37.95 yards. And now we got to go area now. Somebody want to remind me area of a parallelogram? Base times height. Well, I already see the height there. And it's drawn to a base of what? 12. But how are we going to find that height? There's two different ways we could find the height. We could go back and now do opposite and adjacent, do tangent. Or now that we have the hypotenuse, I could also do what? Pythagorean theorem. With the full decimal that you found here. Not the rounded or anything. Full decimal. So you choose right now. All right, you choose. Pythag or tangent. Oh, Jesus. So if you did tangent, it would be tangent of 35 equals 4 over y, now I'll call it. Opposite over adjacent. 4 divided by tangent 35. So I'm getting 5.71259. 2027. And I'll plug that in for the area. Bless you. Calm it down. And what do we have here? 13. Final area when you're ready. There we go. Before we end it today, I'm going to give you a little, because we're going to go to a Regents question here. Just a little heads up. One of the problems tonight, it's on your assignment sheet, but in case you don't read the assignment sheet, one of the problems changes units. Like it's in inches, but I want the answer in feet. Okay, so be aware of that tonight. Whoa, 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 whoa.